may, they don't have to, be symmetric. They may be symmetric. There are two types of symmetry. And let me just show you a couple of graphs, and then we'll analyze them and we discuss them. See the graph on page 250, problem 33. I could fold the graph with respect to the y-axis, and it will be a complete overlap. So we say that this graph is symmetric with respect to the y-axis, because if I fold it, it's complete overlap. Now let's take a look at the graph from same page, problem 34. See, in this particular case, I cannot fold the graph with respect to the y-axis, because the graph that I see in the first quadrant does not appear in the second. A function will never be symmetric with respect to the x-axis, because by the vertical line test, it will not be a function. But look what happens here. If I fold this graph with respect to the origin, see what happens? A complete overlap. This overlaps with respect to the origin. Those two are symmetric. Now the same thing with the last graph here, 35. Is this function symmetric? Yes, but not with respect to the y-axis. Again, with respect to the origin. This and this. So, two types of symmetry. WRT with respect to the y-axis, WRT with respect to the origin. This function will be called even function. Doesn't have anything to do with even degree. It doesn't have anything to do with even numbers. That's the name. If it's symmetric with respect to the y-axis, the function is called even. If it's symmetric with respect to the origin, the function will be called odd. It has nothing to do with odd degree of a polynomial function. It has nothing to do with odd numbers. It's just called odd function, even function. Okay, so let's graph one in each category. Here it is. If this is not a good color, please tell me. So this is a function that I could fold with respect to the y-axis, and it will be completely symmetric. The graph that I have in the first quadrant overlaps over the graph from the second quadrant. And now let's understand what the relationship, there is a specific relationship for these functions. So I'm going to draw a horizontal line, dashed line, and I'm going to identify these two ordered pairs. I'm going to call this one x. This is our function f of x. What do you think this value is? You cannot give me a value, just in the context of what you see, you will tell me this height is the same with what? If this is x, what is the y coordinate of that point, which is here? And this is very important. We wrote it last time several times. Three comma f of 3. 3 comma f of 3. So if this is x, how much is this? Anyone? Can anyone help? So this is f of x. So if I call this point P, because I don't want to put everything in there, so you know, if the x coordinate is x, the y coordinate has to be the value of the function for this number, whatever that number is. In the same way, can anyone give us this point? What will be the x coordinate of this point? What do you think? Anyone can come up with something?
-3.
We don't have numbers, so this is negative x, and because it's symmetric with respect to the y-axis, if this is x, this must be negative x. If you mean 3 and -3, I completely agree. Can anyone give us the value here for negative x? What will be this value? And I'm going to call this point Q, so we can write the coordinates separately as well. So what would that be?
Negative f of x.
So if this is negative x, what will be the y coordinate? One more time. The function value at negative x. Be very careful. This is not negative f of x, but it's the function value for this value. Perfect. Now I would like you to give me a relationship between f of x and f of negative x. Look at the graph and tell me, what do you think is the relationship between these two?
They're the opposite.
Let's see. This is f of x. This is f of negative x. Can they be opposite? Anyone? What do you think? What is the relationship between these two? And this will be true for any even function. True for all even functions. What do you think?
I guess I'm not quite sure what the question is.
What
are you asking?
Very good. So the question is, what do you think is the relationship between f of x and f of negative x? Is one bigger than the other?
Well, for this graph, is that they're both an equal distance from 0.
Excellent. So they must be the same. This will always be the case for even functions. Any even function. Remember, I drew a horizontal line. These values are at the same, have the same y value. They have to, right? These points have to have the same y value, because we're talking about symmetric function. Great job. That's the answer. Okay, let's move on to the other type. So please keep in mind, for all even functions, if I replace we are going to have examples in a minute. If I replace x by negative x in the function, I get the function back as is. That's what this means. Okay, let's take a look at an odd function now. We're going to graph this extensively in chapter 3. So this is another function, f of x. This time I will not draw a horizontal line. This time I will draw a line that connects a point on the graph in the first quadrant, a line segment through the origin. I picked a point anywhere you want. Draw a line that goes through the origin and continues till it hits the graph again. As you see, my graph is not perfect, but this is an odd function, and this piece from here till the origin must equal this piece from here, from the origin to the other side. If that happens, the function is odd. I can fold it with respect to the origin, and you see, maybe that's better. How could I show this better? So the the piece of the graph that I have in the first quadrant is exactly the same on the other side of the origin in the third quadrant. It has an image, a perfect image with respect to the origin. Okay, so in this case, I'm going to pick this point. I'm going to say this is x. Can anyone now quickly give us the y-coordinate of that point? That's point P. What is the y-coordinate of point P? Anyone? We just did that. So can anyone say what it is?
F of x.
Thank you very much. Okay, on the other side, this must be negative x. Can anyone give us the y-coordinate? Say it again.
F negative x.
Very good, very good. So now I'm going to ask you, what is the relationship between f of x and f of negative x? Like I asked you before, and this will be true for all odd functions. So I'm asking you the relationship between this value and this value, this and this. Are they equal? Are they, what do you think? One is positive, one is negative, so they can never be equal. Here, they were at the same level, so here they have to be the same. But here they cannot equal each other. It's not possible. One is up here above the origin, one is down here below the origin. So the equal symbol will not work between these two values. But what will work? What do you think? These are symmetric. If this is 3, this is negative 3. This must be symmetric. So the answer will be the opposite. So the opposite of negative f of negative x will equal f of x. Because if this is 3, this is negative 3. They will be equal, but with a minus in front. On the other side, it doesn't matter. You can put a negative here if you don't want it here. It doesn't matter. Same thing. One of them is the opposite of the other. Okay, so let's see how we, other than the graph, let's see how we determine whether an equation represents a graph of a symmetric function. So here we have determined whether each function is even, odd, or none of the above. Functions don't have to be symmetric. If they are, it's easier to graph them. Okay, any preference from 37 through 48? Or I will pick? Okay, I will pick 42 first, and you can pick another if you'd like. In 42, we have a function given as h of x equals 2x squared plus x to the fourth. So we want to analyze the function and determine whether it's odd, even, or it's not symmetric. What I would like you to notice from our discovery here is no matter what we are trying to do, we have to determine f of negative x in both situations. And last time we reviewed how to evaluate functions, so I will determine h of negative x by replacing carefully x by negative x everywhere. Simplifying this to the maximum, how much is negative x squared? Can anyone help with negative x squared?
Negative x.
Negative x squared is x squared because negative x times negative x, everything squared will always be positive. everything squared. Everything to the fourth will always be positive. So it turns out that this is, 2x squared plus x to the fourth. Now I'm asking myself basically three questions. Does this equal the original function? If it does, I will say it's an even function. If it's not, then I'm asking myself, does it equal the opposite of the original function? If it does, I will say it's odd. And if it's none of the above, then I will say the function is not symmetric. From here, not symmetric. If it's even, I will say it's symmetric with respect to y-axis. If it's odd, I will say it's symmetric with respect to the origin. If I don't find that it's even or odd, I'll say, sorry, this function is not symmetric. Only one answer is yes. The other two have to be no. There is only one function that is odd and even at the same time, but nobody cares about it. It's y equals 0. Okay, so is this function identical with the original one? Yes?
Yeah.
Yes. So I'll cross out the other two. I'll say the function is even. So I conclude it's symmetric with respect to the y-axis. Okay, let's take a look at
That was fast.
I'm sorry? Say it again?
Oh, I didn't know that was just, that's it?
Yep.
That's how we solved it. Okay.
Yep, we determined using the properties. So this is the property for an even function. This is the property for an odd. I determined what I needed to determine, and I tested whether it equals f of x. If it equals f of x, I don't need anything else, and I'll say it's even. If it doesn't equal f of x, then I'll check if it equals negative f of x. And then I'll say it's odd. If none of the above, I'll say not symmetric. It's a function that has no symmetry. Okay, so let's take a look at one more, unless you need more. Let's say 37. We have f of x, which is x to the third plus x. Okay, and we are asked to find whether it's symmetric or not. All I have to determine is f of negative x for now. I replace negative x by negative x everywhere, like we just did, because we know what the function is telling us. And can anyone help with negative x to the third and simplify that without parentheses? Anyone? Negative x to the third, very good, and minus x. And remember, I have three questions. Or we have two questions. The last one is none of the above. This has to be equal to f of x or negative f of x. If I say yes to the first one, then it will be even. If I say yes to the second one, then it will be odd. So I look at what the result is of f of negative x. Does it equal the original function? If it equals the original function, we're done. We don't have to do research anymore. Does it equal the original function? No. Does it equal the negative f of x? I don't know. I haven't calculated negative f of x. I'm going to multiply both sides here by negative 1. When I multiply this side by negative 1, I get negative f of x. When I multiply this side by negative x, I get negative x cubed minus x. So now I'm asking myself this. Does the f of negative x, does it equal negative f of x? If you say yes, then I'll cross out the last one and I'll say it's odd. If you say no, I'll cross this one out and I'll say it's not symmetric.
Question, which one do you multiply?
Which one do you think?
-1, you said, right?
I multiply the original function, it's negative f of x, right? The original function by negative 1. Negative 1 times f of x, negative 1 times x cubed, negative 1 times x. I multiply the original function. It's right here. Negative f of x. If I multiply this side by negative 1, I have to multiply the other side by negative 1. So I'm coming back to the comparison. Does this, which was f of negative x, does it equal negative f of x? Is it a yes or a no?
Yes.
Excellent. It's the same. So I will say the function is odd because f of negative x equals negative f of x. This that I just calculated equals this that I just calculated. They are identical functions. So the function is odd. Are we okay with this?
One question.
Please.
Do you always multiply negative 1 to check if it's odd?
Yes, because
Okay.
I need to analyze or determine f of negative x and negative f of x. Only if these two are equal, the function is odd, which I don't have to do for the even. For the even is only basically one step. I determine this and compare them. Done. Yes or no. But here, perfect question. Here I have to determine f of negative x, which I did. It did not equal f of x. So now I'm forced to determine also negative f of x and compare these two. If they are equal, I'll say it's odd and I'm done. If they're not equal, I'll say the function is not even, it's not odd, definitely it's not symmetric. Very good. Any questions? Is this okay so far, everyone? Okay, so moving on. So that's one important information about functions. Here is another. Max/min and increasing, decreasing intervals. So let's take a look at the graph. So max, min, and increasing, decreasing intervals. I'm gonna graph a function, and then we'll look at problems in the book. So let's say it's this. So notice what I did. I took my marker and I started going up. So the function is increasing. The function values, the y values are increasing till this point. And then the function is decreasing. The y values are decreasing till this point. When the function now starts, the y values start increasing. So this is our f of x. I'm going to put some numbers here because I need them. Let's say 2 and 12. I'm also going to put some numbers here. Let's say -3. And here 4. I just made them up. Okay. I will say the following. F is increasing on, when we are talking about x values, between -infinity and 2. On this piece, for x values between -infinity and 2, the function is increasing. I'm not interested from which value till which value. No. In the trend, from -infinity to 2 for x, the function is increasing. Also, between 2 and 12, between x equals 2 and x equals 12, the trend is decreasing. Finally, between 12 for x between 12 and infinity, the function is increasing. And that's what I'm going to put in writing. The function is increasing on the interval negative infinity to 2, union 12 to infinity. And I'm going to say that the function is decreasing on the interval only 2 to 12. Because the function is increasing and then decreasing, this point, it's called, hello? No, it's not an urgent message. 2 to 12. Forgive me, I keep the phone on just in case a student cannot get in or something. So this is called a relative max. It's not an absolute max because there are other values of y that are higher. But it's a relative max because left and right, the function has lower y values. So this point is a relative max. 2, 4. 2, 4, relative max. Now, there are two questions here. Where is it? You must answer x equals 2, at x equals 2. And the question, how much is it? You have to say max 4 or y equals 4, whichever you prefer. So the position of the relative max is given by the x position. The value, the altitude, how much is it, is given by the y value. What do you think this point will be? 12, negative 3. What do you think we're going to call that point?
Relative minimum.
Great job. So relative minimum. If I'm asked where is it, I will say at x equals 12. If I'm asked how much is it, I will have to say the minimum is negative 3 or y equals negative 3. And now with all this information, we are ready to go through a big question. Look at how many questions, how many parts. You choose any problem you want. 49,